Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We are starting a brand new unit right now. We're going to start looking at integers. Now you would have looked at integers in grade 6, but in a very basic form. We're going to get a little more detailed with integers now. But today I want to do a little review of what integers are. So what we have here is a really good visual representation of what integers are. An integer is both a whole positive or whole negative number or zero, okay? So integers include 0, and they include positive numbers, and they go on forever in the positive direction. And as we get farther positive, as we go this direction, in the positive direction to the right, the numbers increase in size, okay? The numbers get larger, okay? And integers also include negative numbers. And as we go farther in the negative direction, as we go this way, integers decrease in size and get smaller. Okay? That's what an integer is. And also as well, if there's no sign in front of an integer, it still is positive. So we would say positive 1 or 1 is the same thing. Positive 2 or 2 is the same thing. But if we're talking about negative integers, those have to have the negative sign in front of them. Now let's talk about some real-life representations of integers. So we're going to write an integer for each of these. Most common example of an integer is temperatures. 7 degrees below Celsius, we would say is negative 7 degrees Celsius. Going up 4 floors on the elevator would be positive 4 floors. Owing someone $50. Well, if you owe someone $50, you're negative $50. But it could be the opposite. If someone who is gaining that $50 would be positive $50. 150 meters above sea level, that would be positive 150 meters. Moving back 4 spaces would be negative 4 spaces. And in golf, if you've ever played the game golf, 5 shots under par would be negative 5. And in golf, that's actually a good score. So those are some real-life applications of integers. Now, another topic we have to look at in integers is opposite integers have the same digit, but the opposite sign. So if we wanted to state the opposite of each of these integers, the opposite of negative 7 is positive 7. The opposite of positive 24 is negative 24. The opposite of negative 267 is positive 267. Okay? So that's another term you have to know. You have to know opposites. Now, last thing we need to be able to do is put integers in order. I actually want to change what this instruction says. I'd like to order them from smallest to largest. You could also order them from greatest to smallest, but I'd like to start with smallest to largest. All right, so if you look at the first set of integers, and if we're starting with the smallest, I always like to think like temperatures. What's the coldest temperature here? The coldest temperature would be negative 4. That's the smallest. Then negative 2. Then 0. Then positive 1. Then positive 6. And in number 2, again, if I think what's the coldest temperatures, well, going from smallest to largest, I'd start with negative 13, negative 4, negative 2, negative 1. And then number 3, going from smallest to largest, I'd do negative 6, negative 3, 0, positive 3, positive 6. And the last one, if I keep thinking of what's the coldest temperature, we'd have negative 36, negative 22, negative 1, and then 0 would be the largest integer in that group. So it can be a little bit deceiving, right? Like this is a question I often see kids get confused. If I have the integer negative 5 and negative 2, which integer is larger? Well, negative 2 is larger because it's the warmer temperature. So that's a little introduction into integers. That gives you all the information you need now to complete the assignment, the 2.10 and the 2.11 page. I hope that helps. That's all for now. Flexing Teacher Weber, out.